Alright, so we're going to go over a really short, quick, and simple introduction on how to solve exponential and logarithmic equations. So first of all, when you look at this first example here, this is called an exponential equation since your exponent has the variable that you are solving for. And in order to get this exponent solved for, we have to use what's called a logarithm operation, or you could do change of base, but I'm strictly just going to teach you how to use logarithm operations. So if I want to solve for this one, my goal is to figure out what x would be. What power can I raise 5 to so that I equal 125? To do so, there's an operation called a logarithm. Since I want to get rid of the base of 5, I'm going to do a logarithm base 5, which is how you read this, to both sides of the equation. And I will go over in just a moment what a logarithm actually does. So since I'm taking a log of both sides, I'm going to place the 5 to the x power on the left and 125 on the right. And what happens is a log base 5 will cancel out the exponent base of 5 and drops down the exponent of x. So basically it is solving it. And what this reads right now, what does a logarithm operation do, is this mental question. It solves what power can I raise the base to? So what power can I raise the base 5 to? So that it equals whatever is inside. So what power can I raise 5 to so that it equals 125? That's exactly what log does. Now, some of us can already figure it out. Well, 5 to what power is 125? And we should know that it's a 3. So I already know ahead of time that 5 cubed is 125, so I can solve it just by doing some math in my head. But if you didn't know that, the calculator will compute that. And sometimes it's harder to do in your brain, especially when you have decimals and whatnot. So this is how you get to it in your calculator. You're going to hit the button that says math right here. And then hit the top arrow because it's a lot faster. It's at the bottom of the list. And you're going to scroll to where it says log base. And when you go to log base, it's going to open up this template and we fill it in. We want a log base 5 of 125 and voila, we get 3. So then if I plug 3 back into here, 5 to the third power is 125. We solved it. All right, so what about when it gets more complicated, such as ones like these? Well, for instance, I can't do this in my brain either. So we're going to go and follow inverse operations. We're going to isolate the exponential piece. So what do I mean by the exponential piece? Well, you see that the base is 16 and the variable that we're solving for is in, and it's in the exponent. That means I want to isolate this section by getting rid of this 5 before I use my logarithm. So let's go ahead and do that. Draw a line down the equal sign. In order to get rid of this plus 5, we're going to subtract 5 on both sides. Drop it down, 16 to the n minus 7 equals, 19. Okay, so now when I look at the left side, we have the exponential piece isolated. We have 16 to the n minus 7. But in order for me to solve for n, I have to get rid of that exponent base. So to get rid of the exponent base, I'm going to take a logarithm base 16 of both sides of the equation. So I take a log of the left side, the 16 to the n minus 7, and a log of the right side, the log of 19. And what happens is the log base cancels with the exponent base, and we drop down n minus 7 equals log base 16 of 19. Now instead of putting this in my calculator right now, I'm going to get n completely by itself and then type it in my calculator. So that way I can get the most accurate answer without rounding. So I'm going to add the 7 first to the other side. Notice I took the log of 19 before I added 7. Therefore, I cannot put 19 plus 7 inside the log. I have to keep the 7 outside of the parentheses. So now that n is by itself, I'm going to put n is about, because I know ahead of time that we're going to get a decimal. And when we get a decimal, we're going to use the about symbol when we round, because you cannot use equals if you are rounding. All right, so here we go. In my calculator, I go to math, scroll up to log base. We had log base 16 of 19. And then on the outside, we went and added 7 to this. So I get this crazy decimal, we're going to round to the hundredths place. That 1 will keep the 6. It will not round the 6 up. Therefore, I'm going to say it is about 8.06. And there you go. Okay, let's go ahead and do one more on here, and I think number 3 looks pretty good, and then we'll go ahead and do the opposite of this, which is solving logarithm equations. All right, so on number 3, if we're solving for this, again, we want to isolate the exponential piece before I apply a logarithm. That means we need to get rid of that 5 that is being multiplied to it. Let's draw my line down the equal sign. In order to get rid of multiplying by 5, which is attached, I need to divide by 5 on both sides. Now I get 6 to the power of 3m equals 4. Okay, now I can apply the logarithm since I got the exponential piece isolated, and I need to get rid of a exponent base of 6. So I'm going to take a log base 6 of both sides of the equation. Drop down the left side, 6 to the 3m, and drop down the right side, the 4. So we can cancel off the log base with the exponent base, drop down 3m. And again, before putting this in the calculator, go ahead and get m completely by itself. So I'm going to divide by 3 on both sides and put it in our calculator like this, and we'll round to get what m is about. Okay, so math, log base 6 of 4, and then on the outside, we divided it by 3. And we get about, that 7, since it's bigger than 5, we're going to round the 5 up 1 value, so this would be about 0.26. Okey-doke. All right, so now let's go ahead and move on to the opposite of this. We're going to solve logarithm equations. So to solve a logarithm equation, we're going to do the opposite, which is to raise the base to the log as an exponent. So we want to write both sides of the equation as an exponent, since an exponential and a logarithm are inverses. Okay, so down here we have a logarithm equation. It says log base 5 of x. That's how you would read that. Now we want to undo this and basically write this as an exponent. So we know that the base is going to be a 5, and we want to write this as an exponent. It looks a little weird. So what I'm going to do is I'm going to say, okay, well, the base is 5, right? That means I want to put all of the left side and all of the right side as the new exponent. So on both sides, we're going to keep the base of 5, but we're going to raise these as the exponents. Log base 5 of x and 5 cubed. Notice, I used whatever the base of the log was. I wrote it at the bottom as the base of the exponents. So what happens here is you basically rewrote a logarithm in its exponential form. So you know that this is the same thing as saying 5 cubed, which if you look back at the previous one, 5 cubed is 125, and we just rewrote the logarithm as an exponent. So instead of us asking what power did I raise the base to, we already know what power we raised the base to. We raised it to the 3rd power. So when you know the base of the log, whatever you are equaling becomes your power. And basically what this does is you're following an exponential operation. What did I equal by raising the base of 5 to the 3rd power? So what did you equal by raising the base of 5 to the 3rd power? So when you plug it in your calculator, of course we already know the answer. 5 cubed is 125. So we get x equals 125. All right, so let's go ahead and do some more difficult ones following the same type of method. Just like before, we want to use inverse operations to isolate the logarithm section. So if you look at this example here, this is your logarithm. You want to get rid of all those outside values following backwards PEMDAS before raising them to an exponent. Okay, so the -1 is not attached to the logarithm. We want to get rid of the -1 first by adding 1 to both sides. And then we drop down 2 times log base 3 of 9x plus 2 equals 8. Okay, again, the logarithm is not isolated yet. So now we need to get rid of that 2 that is attached to the log, meaning it is being multiplied. In order to get rid of multiplying by 2, we divide by 2. Then I also divide 8 by 2. Drop it down, we get log base 3 of 9x plus 2 equals 4. All right, so then now what do I do from here? Well, from here, we follow exactly the rule that we just did above. Okay, so what we did above is we said, okay, if I have a log, we want to rewrite this in its exponential form, which means the base is going to be a 3, and the 4 becomes my exponent. Okay, so I'm going to raise 3 to the power of log and 3 to the power of 4. And what happens is we drop down the exponent because now we wrote it in its exponential form. And we continue solving. So we can put 3 to the 4th in our calculator to see what number that is. Sometimes you get a really huge number and it's best to leave it as an exponent until, like I said earlier, you get x fully by itself. Okay, so we'll see what it gives us. Obviously, this one's not going to be that big because it's some small numbers. We get 3 to the 4th, right? So 3 to the 4th is 81. We're going to go ahead and write it as 81. And now it's basic solving. Get x by itself. So subtract the 2. And then we're going to divide by 9. Okay, so now we can leave this answer as its fraction form. Since 79 and 9 do not share any common factors, it will not reduce. Or we can go ahead and put it in our calculator and get its decimal value, which looks like this. And again, we can round it to the hundredths place and say this is about 8.78. So either of these is acceptable in this case. All right, so usually with logs we get some crazy numbers. We're gonna go ahead and do another one that's kind of weird like that. I'm just gonna invent one randomly. All right, so let's invent one. Let's say 4 log base 5 of, I don't know, 2x minus 3 equals 13. That'll work. All right, so from here, again, we want to isolate that log. So the minus 3 is not attached. Get rid of the minus 3 by adding 3. Drop it down. And now we want to get rid of the 4 that's attached to the logarithm. So I'm going to divide by 4 since it's multiplying. And finally, we have the logarithm by itself, so we want to rewrite this in its exponential form, meaning log base 5, we're going to raise both sides as the new exponent with a base of 5. So we cancel off that log, and we rewrote it as its exponential form. Okay, last step, x is not fully by itself. We can get 5 to the 4th power, or we could get x by itself and then do it later. So let's put this in our calculator and see what we get. All right, so here we go. We get 5 caret, hit this button right here to get to the exponent to the 4th power. Make sure you hit the right arrow to get down from the exponent and then divide by 2. So we get this as our answer, 312.5, which is a pretty number, so we don't even have to use the about symbol since there was no rounding necessary. It is the exact answer. All right. So to recap, you have 2 operations. You have, when you have an exponent, for instance, This is an exponential. What you want to do is a logarithm with the same base to cancel. Okay? If you have the opposite, if you have a logarithm, then you want to use a exponential to cancel, which means write it as an exponent. So the base would be 4. I would raise it as an exponent, 4 to the log power, and then cancel to get x. Okay, so these are your inverse operations. Regardless of what the base is, you can use a logarithm to rewrite it.